Hi, I'm the Magic Mirror, and in this video you are going to learn how to make me talk. You will use ROS Development Studio to learn the basics of sound generation in ROS. After that, you will apply it to generate sound in Raspberry Pi. Thank you very much, and enjoy the video.
Hi, and as you heard in the intro, this is a video continuing, this is part 3, and we will continue with this face tracking, and also all related to creating this living magic mirror, let's say. This is the name I put the project. So in this video, what you are going to learn is how to generate sound with ROS in Raspberry Pi. For that, as in all the videos, we are going to use ROS Development Studio, which is a web-based development platform for ROS, and you can find it in theconceptsync.com, ROS Development Studio, and we are going to develop most of the code there, and then we'll just test it in Raspberry Pi, which is the way to go, really. So, first things is, okay, where do we start? So, let me just show you. So, if you go to ROS Development Studio, when you launch your empty simulation or your simulation, you'll get something like this. I've just opened the IDE, it's right here, and I have it already prepared. So let me close this just to make it a bit easier. So what I've done is, based on what we did in previous videos, that we did this Face Landmarks package, if you remember. If you didn't see it, please click in the card that I'll put around somewhere in the video. And this was for face landmark detection. And today we are going to work with this Magic Mirror sound package, which I created. Basically is a ROS package that depends on two things, which is RaspBerryPi and SoundPlay. And SoundPlay is the cornerstone of this tutorial. And basically, if you're going to work with sound in ROS, you have to use and know how to use this package. So let's go to the documentation just to show you. So SoundPlay is a package that is inside a stack, which basically is audio common that has loads of packages related to playing sound, recording sound, and so on. But we're going to use SoundPlay. SoundPlay, as the name implies, is for playing many kinds of sounds. Basically, we are going to use it for two things. One, to play sound files like MP3s or WAV files. And the other, and most important, and is the objective of this video, is to do text-to-speech, which text-to-speech is you write a text and you'll get some robotic character talking, as you heard in the intro. So, how are we going to do this? So let's go back to our package. So the only thing that you have to do to have this running is start this node. I've created a launch file just for convenience, but basically you could do ROS run SoundPlay server, SoundPlay package, and the type SoundPlay node. This will launch the SoundPlay server that will be hearing all the requests to play sounds. This is really useful because you can, for example, launch it here in ROS Development Studio and call it from another system, like, for example, Raspberry Pi. So this is quite simple. You just have to launch this server and then you have to use the API. You have a C++ API and a Python API. So let's have a look. How do we call it? So this is SoundPlay test. This is not made by me. It's the test script, basically, just modified a bit for some stuff, but basically is the testing script. If it works, SoundPlay works in your system. I won't go in depth on how this works because that would be like a full course. If you're really interested on that, please leave it in the comments below so that we can maybe, if a lot of people ask it, do a course centered on SoundPlay and how to use it, and we'll post it in RobotIgniteAcademy as one of our main courses for this. So if you're interested, please leave a comment below saying that I'm really interested in sound, please do a course, and if you're lucky, maybe we can do one for you. Okay? So essentially how this works is you go here and you need SoundPlay messages, sound request, and also we are going to use the libSoundPlay, which is the API for Python, and we are going to use this sound client. Okay, so we just initialize a ROS node like always in ROS, and we create this sound client object. And with this, basically, you do everything. You can stop all the sounds that are playing at that moment for whatever reason. You can play WAV files. You can also play some sounds that has this system installed. So you have some really, well, just for testing, if you don't want any WAV. And then the most important part, and the thing that it's for me more interesting, is voice to sound, so text to speech. You only have to create this sound handle voice sound with the text that you want it to say, and then you just do S3, for example, S4 repeat or play. Repeat will repeat this again and again and again until you execute another command. For example, this one will repeat again and again and again until this one comes in, okay? Because this is asynchronous, so you just send it to the service and it just executes forever and ever. But if you execute another one, then it will stop the first one and execute the other one, okay? But you can use also play. Play just will play it once and that's it, and then stop. This will stop, in theory, S3, but it won't. It just gets stopped because you played this one before. So you have to bear in mind that it's asynchronous, but basically that's how it works. Okay, so if we launch this launch and we play this Python API, well, this script basically, we should generate sound. So in a normal system, so in your local computer, that's enough. You just have to do this. But because we're using ROS Development Studio or any server-based system that you don't have physical access to it, you need some way of, well, hearing the sound. Luckily, because ROS Development Studio is a web-based system, it allows us to do a lot of things. And one of them is hearing sound and playing it. And here is where this comes in. So this code is not mine also. I leave all the code that it's not mine. Basically, I leave it in the description box, sorry. And I leave it there, and it has more details that I'm giving. I'm just going to show you how to use it. So what we're going to use is a Python notebook. So if we go here, and we go to Jupyter Notebook, then we can generate Python notebooks here. So essentially I've created a notebook with that code inside. And this, what it does is allows you to play sounds in Python notebooks very easily, very, very easily. So I leave in the comments below in the description box this function because it's really handy, really nice. But I'll concentrate on this. So once we have this function, we can call and play sound files like this. That's it. It's super easy. So we'll concentrate on, okay, how do I capture the server system sound and I store it for later playing it? So that's what I'm going to show you how to do here. So we are going to use pyaudio for this. I'll leave also in the comments how to install it, but basically it's a sudo pip install pyaudio. That's it. Nothing very fancy. But let me show you exactly what you have to install. So you have to install this for play audio, and this to make pyaudio work. Okay. So once we have it, I've just declared this class which will capture when we stop or when we Control C, basically so that we stop recording. And then we create this, we initialize the class, we initialize with the variables for getting a stream of audio data. We get it through chunks of, I think it's 2000 something. So if you do 2 multiplied by 11, yeah, there we go. So 2048. So basically we put a chunk like that, a rate, the channel, very important. The channel is the channel number 1 normally is the system audio, but if you want to record from a microphone, then it will be another channel. So bear that in mind. And then the format, also very important, and the name of the file that we'll record in, which is in this case system recording WAV. And this is just a value so that we can print the sound peak. This is like a debugging so that we can see. In this case I've deactivated, but it allows you to see more or less if it's recording some sound or not. And then we start the stream. So we create this stream object, and then what we do is from the stream we read a chunk with this type, and then we transform it into a NumPy in this case, and we do all the transformations to print it. But in this case we won't see this, so we just are going to do data stream and get a chunk. That's it. And then what we do is append that data into an array which is frames, and here is where we store all the sound data, and this will continue to play until the end of the days when you hit stop or Control C, depending on how you execute this. Once you have it, then it will store from frames all the data like this and store it in our wave output file. And then we will be able to execute it and hear it. Okay, so want to hear it? So let's have a look. So the first thing is I'm opening a web shell, which you open like this. You go here, web shell, and you click there. Then I'm going to launch my Magic Mirror start SoundPlay server. Let's remember, it's just initialize the play sound server. And then we are going to play the sound. So let me just select the test. There we go. Python sound playtest. Okay. And before we do this, we go here to our notebook and we initialize this. We now hit play. It says recording, you see here. And now we can start playing the sound. Great. So here we go. Now we hit stop and you see it got you press Ctrl+C, finish recording, so it will just stop and save all the data. And then we execute this magic function. Yeah, it will take a while just because it has to load the file, which is some megabytes. So it depends on your internet connection, so bear that in mind. And then you hit play. So what I'll do is, because otherwise it's quite difficult to record, but I'll just play the sound that I'm hearing. I'll put it in the video so that you can hear it loud and clear.
Beep.
Warning, low battery.
I'm afraid, Dave. Dave, my mind is going. I can feel it. I can feel it. My mind is going. There is no question about it. I can feel it. I can feel it. I can feel it. I'm afraid. Good afternoon, gentlemen. I am a HAL 9000 computer. I became operational at the HAL plant in Urbana, Illinois on the 12th of January, 1992. My instructor was Mr. Langley, and he taught me to sing a song. If you'd like to hear it, I can sing it for you. Go.
Beep.
Yeah, so there you have it. So as I said, I'll just put the sound directly in the video so that you can hear it loud and clear. But that's how you get the sound playing. Yeah, fantastic. So you heard a snippet of the conversation of HAL 9000 of 2001 Odyssey in Space. If someone is a fan of that, then that was it. Yeah, and this is the first part of the video. So the second part, what we are going to do is do the exact same thing, but we are going to play it in Raspberry Pi. So in this case, how do we do it? So what I've done is, so I've connected through SSH to Raspberry Pi. So if you don't know how to do it, please go to the first video of this series where I show how to connect to Raspberry Pi through different methods. Essentially, we have here two windows connected to the Raspberry Pi. So now I'm going to connect Raspberry Pi's, yeah, I'll show you in a video maybe, but basically I have a loudspeaker, a speaker connected directly to Raspberry Pi. And now I'm going to do the exact same process. So we just launch our start SoundPlay server, which, as you can see, let me show you just here, source, Magic. So I've downloaded Magic Mirror package, and you see that we have our sound package that we use, the exact same one. So we are going to launch the sound server, and now we are going to execute another one, which is a much shorter one, which is, if you go here, if we go to ROS Development Studio, and I generated this HAL 9000, which is much simpler. It just executes this text, and that's it. And it waits for 45 seconds, but I mean, it stops much. You can stop it and nothing happens. So let me execute this. Hope we can hear it.
Good afternoon, gentlemen. I am a HAL 9000 computer. I became operational at the AJL plant in Urbana.
Okay, so there we have it. So as you can see, you can develop your code without any problem in ROS Development Studio. You can test it, you can do as many things as you want, and once you have it working, then you can just download it to Raspberry Pi and execute it. Even you don't need to download it, because you remember that SoundPlay package is a server-based system. So essentially, it can talk through ROS. So we can just execute the test. You can execute the test here. And if you do a OpenVPN, which we explained in the first video, you could see all the topics and access all the systems in ROS Development Studio. So you would have the server running, and you would only have to execute this, and it would play the sound. So great for us here. So I think that's quite it. Thank you very much for staying until here. If you like what you saw, please leave a thumbs up, and please subscribe, hit that bell for more content. We do videos, we publish videos every day, we do webinars and so on, live classes. So please stay tuned and see you in the next video. Bye.